continuing on with 4-5. This will be a carbon dating problem. This is radioactive decay. This is how they figure out how old an item is when they discover an item in archaeological digs. And so this is how they date those things, figure out how old they are. So we're going to be given a little bit of information. Here's part A of this question. We are going to use the fact that carbon-14 has a half-life of 5,715 years. And we're going to find a decay model. Okay, what a half-life means is that is how many years it takes for there to be half of the carbon remaining in the item. Whatever the original amount of carbon is, it takes 5,715 years for half of it to be gone. So we're going to use our same exponential function that we were using for population growth, but now it's going to be a decay model. Now, remember, A stands for the new amount, O stands for the original amount, E is on our calculator, that's a value we've been given. K is our constant that is either for growth or decay, in this case it'll be decay, and T is time. It looks like this, in this situation, they have not given me enough information, because all I have is this, which is time. However, they did say it would be a half-life, which means my A value is going to be half of my original. So instead of A, I'm going to plug in 1/2 of AO. And that needs to equal AO, E, to the K times 5,715. Now, in this case, my AOs, if I wanted to go about trying to get rid of AO and I divided both sides by AO would completely cancel. So I can just go ahead and cancel them out. And I now have 1/2 equals E to the K times 5,715. And now we're going to go ahead and just do this as a logarithm. So I'm going to write natural log on both sides. That way I can bring that exponent down onto the line because I need to get the K down here where I can find it. So I have natural log of 1/2 equals K times 5,715 natural log of E. We all know what happens to natural log of E. It cancels. And now I'm going to divide both sides by 5,715. So I'm going to plug that into my calculator. Natural log of 1/2 divided by 5,715. And I get this value. Now, this is expressed in scientific notation. That's what this E to the -4 means. So I'm going to leave that value in my calculator because I'm going to need it later. But if they ask you for it, you've got to go ahead and move that decimal back 4 places. So my value is going to be -0.0001213. And the computer will tell you how many decimal places they need you to round to. Now, part B of this same question asks me to actually find how old something is. And it says that when the Dead Sea Scrolls were found, they contained 76% of the original carbon. And the question is, how old were they when they were found? So we're going to use the value that we just found, and again, we're going to use our exponential decay model. So A equals AOE to the KT. I now know K and I'm looking for T. In this case, again, they didn't give me the actual amounts, but they did tell me that it was 76% of the original. So I can put 0.76 of AO has to equal AO. E to the negative 0.0001213 T. And now I'm solving for T. And just like what happened earlier on, my AOs will just cancel right out. And I have 0.76. I'm going to write it as a natural log so that we can bring that information down on the line. So I have natural log of 0.76 equals natural log of e to the negative 0.0001213 t. All of that was written up there so that I could bring it down onto the line. We all know what's going to happen, so let's go ahead and do that. Cancel out our natural log. So I have natural log of 0.76 equals negative 0.0001213 t, and I'm going to divide by that. And that's going to give me my t value. So I'm going to go to my calculator and just do natural log of 0.76 divided by, and that value is held in my calculator, so I'm just going to put that in, hit enter, and I get 2,262.7. And of course your computer is going to tell you what you need to round to. Be careful to follow all the instructions on rounding. If it tells you to round your intermediate values to 3 decimal places, then that means that during this process I would have rounded this number to 3 decimal places because I'm using that in the intermediate while I solve. And it will make a difference for your final answer if they have you doing rounding in between. So that is a carbon dating problem.